Welcome to this video on using numba. So numba is a package in Python which you can use to speed up your code. So here I will been importing numba as nb. So let's just run that. So we have talked about in another video on speed up that you can vectorize your code and that can make the code faster. But sometimes that's very cumbersome, and instead we can therefore use the numba module. So the numba module works by adding a decorator, which is normally nb.ngit on top of the function, and tells numba to compile this function to machine code just in time. This takes some time the first time the function is called, but subsequent calls are then a lot faster because the code is optimized. But it's also optimized to the inputs you put into the function the first time in terms of sort of not the numbers, but the types and the sizes of arrays and so on. So you shouldn't change types between calls. But let us have an example. So here I have some function in NumPy, which is a vectorized function, and it looks a bit complicated what it's actually doing. We don't care too much about it. And then we are drawing some numbers, and we are then evaluating the function. And we can see that it takes about 1.2 seconds on my computer to evaluate this function here. So that's a lot of stuff to do. If you do this in numba, then you write the function as a loop. So it's still you have the same output, but you loop through how many x1s are there, and then if x1 is less than something, then you do a sum of the exponential and x2 and then the x1. Otherwise, you do the log of it. So this is just some weird computation. I think this code here, that's considerably easier to read than the code up here, but actually they do exactly the same. They result in the same results. When you call this function the first time, it takes 1.6 seconds to run. So that's actually slower than this, but that's also because it spends time analyzing the code. The second time you run it, it's only 500 milliseconds, so about 3 times as fast than the NumPy vectorized code. And that's showing you that it can be beneficial to use numba. You can also, when you have a number function, you can call the Python version of the function, which using this .pyfunc. That's a very slow thing. It takes almost 8 seconds here. So, but these half second compared to the 1.2 seconds, that's the selling point of numba and the easier code in terms of loops. The caveats are that it's not everything in Python and NumPy you can use here. There's only specific Python functions and specific NumPy functions or features in general you can use. So look in these links here to see what can be done. It's always also a thing that types cannot change. So in this case, I had that the x1 was a uniform thing and the x2 was an integer thing. So you cannot change this to not be an integer in the next round or so. But play around with it yourself and see whether you face problems. The simpler the inputs are, the easier it is to write the number function for it. There's also potentials with number to do a bit of fewer additional speed ups. For example, you can specify in the decorator that it should have allows to do things in parallel. And then you can say that if you want to do this loop over the x1 size, then you want to do this in parallel. So you use the p range, the parallel range from number. And again, you have the exact same results, but now we actually cut the time in half again. So now we're down to 226 milliseconds. You could think that if you have more CPUs, and then this should be even faster than this one up here. If you have 8 CPUs that I have on this computer, then it should be 8 times faster. But it's hard to get these speed ups because some parallelizations might already been in use here without us actually knowing it, and there can be other bottlenecks in terms of speeding it up. Finally, you can also add fast math equal true here, which allows a number to use some more imprecise math, but sometimes faster math. Here it almost doesn't make a difference, but sometimes it can make a difference. So I hope you will try out numba. It can be a very efficient way to create nice, fast running code.